Hello. Today we're going to look at this calculus example where we are looking at the infinite limit involving the function y equals tan x. Well, what I'm going to do is just go ahead and sketch this. That's the first part. Sketch y equals tan x. I sort of don't want to go over any explanation. I just want to get right to it because I think it's one of those functions that we should just memorize. But I can talk a little once I say, oh, no, I'm not going to talk. I'm just going to give the answer. But now I feel like, no, I better talk a little bit about it. But the result is I go on forever about something and then get off on tangents and discussions on this and that. So basic teacher stuff, just talking and talking on and on. Yeah, yeah. One of my favorite kids' books, Stuart Little, when Stuart Little's almost towards the end, he's riding away on his motorcycle, and there's a principal needs a substitute teacher, and so then Stuart Little sits in as a substitute teacher one day. Now I believe I'm getting the name right. Stuart Little, it's a book, and Stuart Little's a mouse, which of course is hilarious, talking mouse. But anyway, so that's great example in literature of a teacher. Okay. Anyway, read Stuart Little by White. I think it's the same White who wrote Charles Webb. Yeah. Okay, let's check out this tangent y equals tan x. So first of all, if I were going to, I'm just going to tell you, which we're not going to find out until later, but if I were going to, in the calculus, if I were going to approximate tangent x by a line, that when at the point where it passes the origin, that line would have slope 1. We'll have to just wait until we get to further on in calculus for that. And in fact, yeah, well, that's all right. Okay, that's just a little fact there. And then, so this vertical asymptote is this vertical asymptote that we see right there is the line x equals pi over 2. Now, by the way, between x equals 0 and x equals pi over 2 is pi over 4. And we're going to see later on in calculus that the graph of tangent x at pi, when x is pi over 4, if it were approximated by a line, the line would have slope 4. So just hold on there. And if you have seen calculus before, then maybe you might want to answer that on your own and say, okay, why is this guy talking about that? Like, what the heck's that part? Why is he saying that? Saying what? What I mean is, why is he saying that the slope as we pass through the origin would be approximated by a line of slope 1, and at pi over 4 approximated by a line of 4? And also, maybe I'm saying something wrong. I'm pretty sure that's true. Oops, it seems that got in the way. Okay, I better move that. Okay, what are we going to do? We're trying to stay cheerful here. Try to, keep positive about doing this math stuff. Keep it all on the up and up, positive energy. So this graph repeats itself. And the period of tangent is pi. It repeats itself every pi. All right, and then we just repeat it. Just repeat. Okay, it goes on forever. Periodic function is what it is. So, okay, I said I wasn't going to explain very much. What's this big thing doing there? Oh, I don't know. How'd that get there? I think that's not what I want to be there. Okay, I'll cut that. All right. I don't know how that got there. All right. So, okay. So, where was I at? Oh, yeah, maybe I'll explain just a little bit. Okay. So, and then there's symmetry. And by the way, I mean, it goes on forever. So at some point, I just have to make a decision of when to stop. I don't want to, but it just goes on and on and on. So infinitely. All right. Okay. Now, let me just give you a heads up, somewhat explanation, but maybe it's just so short. But y equals tan x is the same thing as sine x divided by cosine x. And by the way, when x equals pi over 2, which is where we have at least one of the asymptotes, the first one to the right after the y-axis, we get that sine of pi over 2 is equal to 1, cosine pi over 2 equals 0. You're just going to have to believe me if you don't know that. Okay, and this gives 1 over 0, which is a heads up that we're going to have a vertical asymptote. And vertical asymptotes go hand in hand with infinite limits. Okay, so where we have the numerator is 1 and the denominator is 0, that's undefined. 1 over 0 is undefined. 1 over 0 is not infinity. Some people, I don't know, hope it's not anybody, math people on the internet, writing 1 over 0 is infinity. Yada, don't write that. 1 over 0, infinity, no. What we mean is what we have over here. Oops. Sorry about that. There's a little typing, little LaTeX typing little mistake. That's what I meant that to be. I guess we'll just get away with it. Probably carried it over for all. No, I just did on that one. Okay. What we're getting at is this, is that, oh no. It just looks like I'm becoming incapable of writing neatly. What I mean to write is x approaches pi over 2 from the right. Okay. Now, what was I talking about? I was talking about this 1 over 0 form when x is equal to pi over 2. At x equals pi over 2, we get a 1 over 0 form. That's a form. It's 1 divided by 0 is undefined. But what we get is that as a form. And now this little plus here that I'm putting here means from the right of pi over 2. So here is pi over 2, and I'm going to come from the right of pi over 2. And now I'm going to do this amazing drawing where I draw arrows and they go down, down, down. See, the 1 over 0 is an indication that we have an infinite limit. Okay, this 1 over 0 would mean that the numerator is getting close to 0. The numerator gets close the numerator gets close to 1. The denominator gets close to 0. The denominator doesn't equal 0, it gets very close. And because it's from the right, it's going to be a small negative, and the ratio, it gets larger and larger negative. Anyway, the answer is negative infinity. This down, down, down through the floor, that's an infinite limit. It's going downhill. And this is from the left of pi over 2. So see, we find pi over 2. Here's pi over 2, and then we go to the left of pi over 2. And we see that this is just going up and up through the roof. That gives us infinity. Those are vertical asymptotes. Okay? The infinite limits are hand in hand with vertical asymptotes. Let's highlight these answers so that it stands out more, so that the answers are not lost in all the other noise that's going on the page. Let's check out this other one. This is, let's highlight this, what it's approaching. Here we have this negative pi over 2. Negative pi over 2 is over here, and this means to the left, because there's a tiny minus, you can hardly see that, left of negative pi over 2. So the negative, this isn't like this negative makes this negative positive or anything like that. This little dash here, this gal here, means to the left. It's just like this one, this pi over 2 positive number, but that means to the left of pi over 2. Here, the left of negative pi over 2. So let's just go over here. And we see that this is just going up and up and up. What the heck? It just goes up forever. You spend the rest of your life tracking that one. That's going to be infinity also as the limit. Vertical asymptotes, well, vertical asymptotes are lines, and vertical lines are presented as x equals a number. So there's x equals pi over 2. I see that one right here. I see x equals 3/2 pi. That's over here. And they all go along with infinite limits. Then to the left of the origin, I have x equals negative pi over 2. To the left of that, x equals negative 3/2 pi. And so what the heck do we have? It appears to me that the answer is x is equal to an odd number times pi over 2. How can I express an odd number? I can write 2x plus 1. K is a member of the set of integers. So what the heck? Did I just step up to write something even more confusing? But I think you're supposed to maybe have studied a little pre-calc and maybe learned that. That's how you, but maybe not. I don't know, whatever. So if you look at k as a counting number, 1, 2, 3, 4, 2 times 1, 2 times 2, 2 times 3, whichever, 2 times that counting number becomes an even number. So 2k is an even number, and you add 1, and that makes it odd. So that's how we can express an odd number. It also works for 0. 2 times 0 plus 1 is 1, odd number. Put in k as negative 1, so we're getting all the integers here. K is negative 1. 2 times negative 1 is negative 2 plus 1 is negative 1/2. It does seem that I started speaking more quickly. Sort of lost my California drawl for a second and went into some fast-talking speech. What happened? Better slow it down and take it easy. Okay, well, got a lot going on here. A lot to look forward to. Which is, what? What do we have to look forward to? Well, who knows when you're watching this video? It might be around 20 years from now, maybe not. Maybe I'll disappear, but who knows when I'll be around. Okay, so this video here is, what's the date? February 2nd, or no, February 4th, something like that. Yeah, February 4th, 2024. So maybe you'll be watching this like maybe a year from now. Who knows how long videos like this last. Okay, so, gosh, is there any jokes to end with? That'd be pretty awesome if I could think of a new joke each time. I'll tell you what, it's not really a super funny joke, but this is a true story. When my wife and I were dating, it was like, courtship, we went out for dinner, and she looked at me and she said, "You're amazing." And what she meant by that is she thought it was amazing how much I could eat. That's what she meant by amazing. It's pretty funny. Seems like really romantic. See, she said, "You're amazing," but it's just how much I eat. Okay, anyway, that was over 20 years ago. So, okay, you all take care and have a great time studying math. Bye.